Okay, unit reviews. So it's got quite a bit of stuff on it. Graph the function. If you see x second, you know that this makes a parabola, a parabolic curve. Okay, it's a quadratic equation. It's got about 3 different names: parabola, quadratic equation, or parabolic curve. So there's 3 coordinates we have: xy, xy, xy. So this is my vertex coordinate right here. Okay. Now, if there's no parentheses, I'm going to use a and ABC, but there's no b because it goes from x squared to the constant, so there is no b. So on an ABC, opposite of b divided by 2 times a, we'll find our vertex. Well, if there's no b, b is 0, and 0 doesn't really have an opposite, and then I would take 2 times 3. Now, it doesn't really matter if 2 times 3 is 6 or a million. 0 divided by anything is 0. Okay. Then I take the 0 and I add and subtract 1. So I get 1 and negative 1. So then I substitute those values in for x. So 3 and then 1 to the second plus 4 gives me 7. Now we substitute 0 in, and I got 4. Now we put negative 1 in, so I reset it. It better be back to 7, and it is. And the reason why it's back to 7, because negative 1 times itself is still 1, and then negative 1 to the second, 1 to the second have an equivalent product, both 1. So that'd be 7. Okay, so 1, 7. 1, 2, 3, 4, 5, 6, 7. And then 0, 4, 1, 2, 3, 4, and then negative 1, 7. And then there is my parabola. Okay, so you need to label your vertex 0, 4. Now this x of 0 doesn't really mean a whole heck of a lot when we got one number bigger than 0, one number less than 0. Okay, so this is all. But the range, we have this y value of 4. And it looks to me like the 7s, those are greater than 4. And the graph is going up past the 4, so it's anything but anything. It can't go under 4, so then it's greater than or equal to. See these 7s? They're bigger than 4. So if I put a 7 there, it'd have to eat 7. Just visualize a 7 being placed there. It eats the bigger number. Okay, y equals negative 2x to the second plus 8. Okay, again, it's a parabola, so I know I need 3 coordinates. Okay, and this is A, there is no B, and then there's C, because B has an X, AX second, BX, and C. Okay, so opposite of B divided by 2 times A, we'll find our vertex. Okay, so there is no B, so that would be 0. And then 2 times negative 2 is negative 4. So 0 divided by negative 4 is 0. So again, the vertex is 0. Then we take 0 plus and minus 1. So 0 plus 1 is 1, and 0 minus 1 is negative 1. So then I substitute those in for x. Plus 8, and that's 6. We substitute 0 in and we get 8. Now when I put negative 1 in, I better be back to 6. Since negative 1 to the second is the same as 1 to the second, I'm guessing it's probably going to be the same thing. So that's back to 6. So 1, 6. 1, 2, 3, 4, 5, 6. And then 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then negative 1, 6. And now the parabola opens downward because the A is negative. So we still need to label the vertex 0 and 8. Okay, so again, the domain's all, because you take that vertex 0, I got a number higher, a number lower. But that's not the case with the 8, okay? 8, then these numbers are lower than 8, so it would be less than or equal to 8, okay? See, if I were to put a 6 where that y is at, it'd have to eat the 8. It eats a bigger number. 8's bigger than anything you can come up with for y, or equal to it. Okay, now the next one. Y equals negative 4x to the second minus 8x minus 3. So I don't know about you guys, but this again, this is an A, but this time I actually have a B, and that's a C. Okay, so it's still a parabola, but now we actually, the vertex is not 0. It is shifted away from the 0. Okay, so again, opposite of the B divided by 2 times A will find us our middle X. Now there's actually a B, so it'd be positive 8, opposite, and then 2 times negative 4 is negative 8. So 8 divided by negative 8 is negative 1. So then I take the negative 1 and I add and subtract 1. So negative 1 plus 1 is 0, and negative 1 minus 1 is negative 2. And now I substitute those values in for X. Now I'm going to let you in on a little secret. If X is 0, that means this term and this term would become 0, but then you'd still have the negative 3. Okay? Input of 0 can be found because it's a y-intercept. You just cover, your x's wipe out of the problem, but you still got that negative 3 that's not multiplied by x. Just a little food for thought. I put in negative 1, and I get 1. Then I put negative 2 in, and I get negative 3. So 0, negative 3, 1, 2, 3. Then negative 1, 1, so right there. Negative 2, negative 3. Go. So the middle vertex point you label negative 1 and 1. Now domain is all, and let me explain that again, because domain's related to the x, okay? There's your vertex right there, but you got a number that's higher than negative 1 and lower, so that's why it's all. However, the range is a different story. You got that 1, but then the numbers end up being lower, okay? So less than or equal to, because if I were to put a negative 3 in place of the y, okay, it would have to eat the bigger number, the 1. That means y is always smaller, okay, nose points towards a smaller than 1, or equal to it, which is why you have the line. Okay, y equals x to the second minus 8x plus 3. So A, B, C. So 3 coordinates. Okay, this is my vertex, and then opposite of B divided by 2 times A. So the opposite of negative 8 is positive 8, and then 2 times 1. 2 times 1 is 2, 8 divided by 2 is 4. So we take 4 and we add and subtract 1. So 4 plus 1 is 5, 4 minus 1 is 3. Now I substitute those inputs for x. So if x is 5, that's negative 12. Then I substitute 4 in, and that's negative 13. Now if I put 3 in, I'm back to negative 12. Okay, so we need to go by 2's on the y-axis in the negative side because that's where I have my outputs. Now the positives are a part of the graph, but the coordinates I have to make are negatives. So 5, negative 12, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12. Then 4, negative 13, 1, 2, 3, 4, 2, 4, 6, 8, 10, 12, and then negative 13, and then you're back right there. Okay, so you find the vertex for negative 13. Remember, domain's x, range is y. Now this is my vertex, but I have a number higher and lower than 3, so it's just all. All the x numbers are covered. However, the y's, the range is a different story. You got negative 13, then these numbers are bigger than negative 13, okay? So I would use a greater than or equal to sign, and also when the graph goes up, it's greater than or equal to because that's going up. It's going higher than negative 13. When it goes down, it's less than or equal. Okay, now we're going to be solving some equations. Now, unless there's a parentheses involved, we're either going to use factoring properties or linear properties, depending on what I have for my variable. So as I look through that equation, I have x to the second and x to the first. So same variable, different powers. So that is using factoring properties. So there's two answers. Your zero's there, so check it. You have to use factoring properties before you count the terms. You got to have it equal to 0. Now, there's 3 terms, so 1, 2, 3. So it's a trinomial, so it'd be GCF, and then the t-table, trying to find the AC factors of the AC product to add to the middle. So there's no x, there's no negative, then 1, 3, and 40 would just be 1. Okay, so 1 times negative 40 is negative 40, so that would be a mismatch. And it's got to add to get to the b, which is negative 3. So 40 divided by 1 is 40. That adds to negative 39. That doesn't work. 40 divided by 2 is 20. That adds to negative 18. That's too wide. 40 divided by 3 is a decimal. 40 divided by 4 is 10. That's negative 6. That's too wide. Now about 40 divided by 5? 5 and 8. And that adds to negative 3, right on the money. So positive 5, negative 8. And your a is 1x to the second power. So we have x times x. And you can apply your 1 coefficient in the front. But really those don't divide at all. Okay? Only 1 would be the only integer they could divide by. So that'll stay 1x plus 5 and 1x minus 8. So 1x plus 5 times 1x minus 8 equals 0. So we have F1 and F2. So 1x plus 5 could equal 0. 1x minus 8 could equal 0. Okay, you can get rid of the times 1. You're just going to subtract 5, and that's negative 5. Add 8, x equals 8. So negative 5 and positive 8. Okay, now the next problem, we have 4x to the second power minus 49 equals 0. Well, this time we have x to the second only. So we're not factoring there. We're using the linear properties. Fill out how many answers are. There's got to be 2. Collect the x terms if you have more than 1. We just have 1. And then you solve. So by solve, I mean, what do we have for operations on the x side? You got times the second power and the minus 49. So you're going to plus 49 first, then you're going to divide by 4, and then when I see that second power, I square root. So I add 49 first. 0 plus 49 is 49. Then I divide by 4. Now I get a decimal here, and that's okay. It's 12.25, and then I apply the square root. Now remember, that could be positive or negative. So the square root of 12.25 is going to be 3.5. So it's 3.5, negative 3.5. The reason why is because the square root of 49 is 7. The square root of 4 is 2. 7 over 2 is the same as 3.5 or 3.5. Okay, next problem, 3x to the second power minus 27 equals 0. So again, like the last problem, I have x second only. So I'm going to do it exactly the same as I just did the last problem using linear properties. So x is on this side with the times 3 is second power of minus 27. So we get rid of the minus 27 with plus 27. We get rid of the times 3 with divide by 3, and then the second power will be eliminated with a square root. So plus 27, so that's 27. Then I divide by 3, and I get 9. So I find the square root of 9, and that 9 is a perfect square root. It's 3, so it's 3 or negative 3. Okay, next problem, we have x to the second plus 6x equals 10x. Now, unfortunately, we're back to having x to the second with x. Now, there's repeated x's, but that's fine. I'm going to combine those, but it's still factoring properties. So there's two answers. But again, to apply factoring properties, you have to have the one side of the equation at 0, so you can use the zero product property after you factor. So minus 10x from 6x. So you have x second and x and the constant. So 1, 6 minus 10 is negative 4, and then this constant is 0, so we don't need that. Okay. So there's two terms. So it's a binomial, so GCF DOPS. DOPS stands for difference of perfect squares. Now a lot of times I end up crossing this out, but we don't know yet. So you have an x on the end, negative in front. 1 and 4 would just be 1, but it's 1x, so you need to factor out and actually divide by 1x. So 1 divided by 1 is 1. X second divided by x, we have a remainder of x. Negative 4 divided by 1 is negative 4, and the x over x cancels. Now bring that 1x over here, cross it out. Now you have a positive and a negative, and 1 is a perfect square because that's 1 times 1. But x without a power is not. See, it has to be x second to go xx, okay? So you cross that out and write no. So you bring over the 1x minus 4. Okay, and use your zero product property. That's F1, F2. So 1x equals 0, 1x minus 4 equals 0. So we really don't need multiplication of 1. So 0 is the first answer. And here I'd have to add 4 to both sides, and that would be 4. So x equals 4. 0 and 4. Okay, next problem. We have 4x to the second power minus 3x equals 2x to the second power plus 9. So again, unfortunately, I have x to the second with x. So I have to go back to the factoring properties. Obviously, linear properties are much easier and quicker, but that's because x squared and x is a more complicated equation. Okay. You don't have your zeros, so you have to take these out one at a time. So you're going to subtract 2x second, and you can put that under the 4x second, and then minus 9, but I don't think 9 has a place to go, so we hang him out. So then equals 0. Now, I'm going to let you in on something. You're going to put your slots just like you normally would. 4 minus 2 is 2. You do not change the exponent, okay? It stays x second. Changing the exponent is a multiplication or division thing. See, when I do this like term stuff, that's adding and subtracting. Then you have the negative 3, and then the negative 9, okay? So, those are my three terms. So I see 3, so it's GCF table. Okay, so I don't have x, I don't have the negative. 2, 3, and 9 would just be 1. So 1 without x or a negative we don't do. So positive 2 times negative 9, that's going to be negative 18. So it's got to be a mismatch. And the mismatch has to add to negative 3. 1 and 18, that's negative 17. 18 divided by 2 is 9, that's negative 7. 18 divided by 3 is 6. So 3 plus negative 6, there's your negative 3. Okay. So I'm putting these into parentheses. I am not going to the quadratic formula. Okay. I want you doing this. Okay. Don't go to the quadratic formula until either you start with 100, I'll allow you to do it, or if you add and it gets too small, too narrow. Or if you repeat two factors. So a is 2x to the second. So we know we're going x times x, but we're going to place a 2 in front of each of my x's. And 2 and 3, those would just be divisible by 1. But the 2 and the 6 can both be divided by 2. Which is exactly what I should expect, because when I divide by 2, 2 times 1 is 2, bingo. 3 times negative 3 is negative 9, bingo. So we have 2x plus 3 times 1x minus 3. And then F1, F2. set each factor equal to 0. So you subtract 3, and that's negative 3. Then we divide by 2. Negative 3 divided by 2 is negative 1.5. So there's your first answer. Then over here you don't need the 1 multiplier. Add 3, and you get 3. Okay, x to the second power minus 12x plus 30 equals negative 5. So I have x second and x. So again, I am applying the factoring properties. So there's two answers. Need the 0 though to do factoring. So you plus 5, and I think 5 can add nicely with my 30. So I have x second, x, constant. So you have 1, negative 12, and then 35. So that's 3 terms. So GCF and table. So no x, no negative, 112 and 35 is 1. Okay. 1 times 35 is 35 positive. So it's a match. We're trying to get the match to add up to the negative 12. 35 divided by 1 is 35. That's negative 36. Doesn't work. 35 divided by 2 is a decimal. 35 divided by 3 is a decimal. 35 divided by 4 decimal. 35 divided by 5 is 7. So 5 and 7. And there's your negative 12. Now my a is 1x to the second. So x times x, and then we are just going to end up placing the 1 in front. So 1 and 5 can only be divided by 1, and the same with 1 and 7, so they just stay the same. Because 1 times 1 is 1, negative 5, negative 7 is already 35. So F1, F2. So 1x minus 5 could equal 0. 1x minus 7 equals 0. So we really don't need the multiplier of 1. We'll just add 5 to both sides and get 5. Again, don't really need the multiplier of 1. Just add 7 to both sides and I get 7. So 5 and 7. Okay. Next problem. Yeah, it's kind of long, okay? Not going to lie. We have x, this was x to the second, plus 4x minus 9 equals 0. So there's two answers. You have x second and x. So we have to use factoring properties again. So 0's there, check it. And now you see the 3 terms up. So GCF and table. Okay, I don't see x, I don't see the negative, then 1 would just be the GCF. Okay, ABC. 1 times negative 9 is negative 9, so it has to be a mismatch. And it's got to add to the sum of positive 4. So 1 and 9, that's negative 8, that's too wide. 9 divided by 2 is a decimal. 9 divided by 3 is 3. If you had positive 3 and negative 3, that's 0. That's under the 4, so QF that. Once you're too narrow or too small with your sum, you're never going to get back. So opposite of b, opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of positive 4 is negative 4. B to the second, that's 4 to the second, and then a is 1, and c is negative 9. Then a on the bottom is 1. So you have negative 4, 2 times 1 is 2. Now find what's inside of the square root. So 4 to the second minus 4, 1, negative 9. I got 52. So positive, negative. The square root of 52 is going to be 7.21. So we take negative 4 plus 7.21, click equals before dividing by 2. That'd be 1.61. We would take negative 4 minus 7.21, click equals before dividing by 2, and that's negative 5.61. Okay, next one. 3x to the second power minus 9x equals 25. So again, I see x second and I see x. So we have to apply the factoring properties. Okay, where's the 0? We have to have 0, and I don't have it. So I would subtract 25, and that can't go with either of these, so it hangs out. So I've got x second, x constant. So we would have 3, negative 9, negative 25. Now I clearly see that that's 3 terms. So PCFT. Okay, no x, no negative, 3, 9, and 25. Okay, those are just in row 1. So 3 times negative 25 is negative 75, so that's a mismatch. And the mismatch has to add to negative 9. So 75 divided by 1 is 75. That's negative 74. That's not going to cut it. 75 divided by 2 is a decimal. Divide that by 3, you get 25. So that's negative 22, that's too wide. Okay. 4 is a decimal. 5 and 15. That's negative 10, that's still a little too wide. 6, no. 7's a decimal. 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 Decimal, 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 decimal. Now 15 and 5, but I already have that pair, so that means it cannot be found with factoring, quadratic formula. So, opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a. Over 2a. So opposite of negative 9 is positive 9. Then b to the second, so negative 9 to the second. And then a is 3, and c is negative 25. Then a on the bottom is 3. So you have 9. 2 times 3 is 6. Then you find the inside of the square root. 381. So the square root of 381 is going to be 19.52. So 9 plus 19.52, click equals, and then divide by 6, 4.75. 9 minus 19.52, click equals, divide by 6, negative 1.75. Okay, next problem. 5x to the second power plus 8x equals negative 3. So we have x second and x again, so we have to use the factoring properties. So there's 2 answers. 0 is not here, so you have to add 3. Now that can't go with either one of these, so we hang it. Okay, so we have 5, we have 8, and then we have 3. Okay, so this would be GCF table again. Okay, I don't have x, I don't have the negative. 5, 8, and 3 is 1. Okay. So 5 times 3 is 15, positive. So it's a match. and it has to add to positive 8. 15 divided by 1 is 15. That's negative 16. That's too wide. Now dividing 15 by 2 is a decimal, then 3 and 5. So we add those. That's okay. That's the right, circle that. We just have to make it positive 8 because right now that adds to negative 8. So plus, plus. Now a is 5x to the second power. So positive 3, positive 5, x times x. And then you place the 5 in front. Now 5 and 3 can only be divided by 1. Okay. Now these are the same numbers, so we need to reduce those by 5. So that's 5x plus 3. That's going to be 1x plus 1. See, 5 times 1 is 5. 3 times 1 is 3. So 5x plus 3 times 1x plus 1. Okay, F1, F2. So 5x plus 3 could equal 0, or 1x plus 1 could equal 0. So we're going to minus 3, and that would be negative 3. Dividing negative 3 by 5 would be negative 0.6. You could put negative 3/5 if you want, or the decimal. Now we don't need the multiplier of 1. We just need to subtract 1, and that's negative 1. Okay, now in the next problem, I want to change this, okay, because I said so. I want you to put 4 parentheses x minus 3 to the second power equals 16. Now that's a game changer. Now we have this x in a parentheses with minus 3 to the second power. So there's 2 answers, but we cannot distribute. This 2 blocks you from being able to distribute. You have to use the h variable. So replace that with h. So h is going to have a times 4 in front. It's going to be to the second power. It's going to equal 16. Now you have to remember to bring back the x minus 3. Okay, so we see the multiplication. We use linear properties. We divide by 4 and do the square root. So you divide by 4, and that's 4. Now I find the square root of 4. It's 2. Now that could be positive or negative, which is why we don't put those here, we bring them here. And that's why we have 2 of those x minus 3 expressions. So I add 3, and that's 5. Then I add 3, and that's 1. Okay. Okay, now to the story problems. A sports store sells about 50 mountain bikes per month at a price of $220 each. For each $20 decrease in price, 10 more mountain bikes are going to be sold. Find what the store can do to maximize monthly revenue. So you're finding maximum revenue. So maximum, it's like those graphs on the front page. You're finding the vertex, and you're going to find it with the opposite of b divided by 2 times a. So I draw this big parabola in the middle. There's no sense doing the boxes for unit analysis. Okay. So x, y. And I know I'm going to use opposite of b divided by 2 times a. You need that in coordinate form. So we know we're going to need an x to the second because of the u, the parabola. And then an x, then a constant equals y. Now y stands for revenue. Whatever the maximum is that you're finding, revenue is how much money you make, and that is found by multiplying the price times the number of items I sell. So the price is, so first off, before we fill that in, make your dollars items table. So we're $220.50. And what are we doing to the price? We're decreasing it by 20, so minus 20 here and plus 10 here, 10 more. So that's at 200. And then that's 60, minus 20 again, you're at 180, and then 70. Now 220 times 50, 11,000, so it went up. So that's your starting revenue. Now 200 times 60, that's 12,000, so you went up. And then take your 180 times 70. 12,600, you went up again. Now there comes a point where you stop going up because eventually there would be a 0 there, okay? But now that fills out our parentheses, because we know we start with 220 for the dollars, and we start with 50 for the items. Now we're minusing 20 over and over, so 20x, and we're adding 10 over and over. Okay. So now we have to execute the FOIL method. So we take 220 times 50, and then 220 times 10x. Then negative 20x times 50 and negative 20x times 10x. So this is 11,000. This is going to be 2,200x. This is going to be negative 1,000x. This is going to be x second, and then negative 200. Okay, so negative 200 is your x to the second. So there's my a. Then you add these, that's 1,200, and that's your b. And the constant is 11,000. So the opposite of b is negative 1,200. And then 2 times negative 200 is negative 400. Okay, so then I divide these two, and I come up with 3. So 3 changes. So I wouldn't have had to go very far. See, that's 1 change, 2 changes. The third change would have maximized that, but I have no way of knowing that really, unless I just did the table full throttle. So negative 200, then I insert the 3 in for the x's. So we have y, and then we just found y solo, so it means you just insert the other side of the equation. Okay, 12,800. So 3 changes gives me my maximum revenue of $12,800. Okay, and then the last problem finally. A patio's length is 8 less than 3 times its width. The area is 220 square feet. Approximate the dimensions of the garden. Okay, so length and width down there. So draw your rectangle. Okay, now you're not building it outside. You just put length, width, and you just put 220 in the middle. Now, so that's the area. Now it also says the length is, so that means length equals 8 less than 3 times the width. So you put a W variable, underline it, and work your way backwards. 3 times means times 3. Then 8 less means minus 8, but you put that behind it. Okay. Okay, so I set up my concoction for how I do shapes. So you got your length times your width. That's going to be equal to the area. Now the area we know is 220. Now, I can't have 2 different letters in here, so I use this base equation like I would for substitution. Base and replace. So you remove the L and you replace it with 3W minus 8, since that's what it equals. And then here you can just use W. So you have the same variable. Now you need to FOIL. It's really not a FOIL, it's distribution. So 3W times 1W, and then negative 8 times 1W. So this is 3W to the second, negative 8W, and really I can't combine anything. These stay separated. So we have 3W to the second minus 8W equals 220. So I need to solve for W now. So there's 2 answers for W. Or you have W to the second and W, 2 different degrees. You have to use the factoring properties to solve for it. Now you have to get this equal to 0 so you can count the terms on the other side. So I hang that because it doesn't go with anything. So I have W to the second, W, and the constant. So you have 3, negative 8, and negative 22. Negative 220. Okay, so 3 terms, GCF table. So there's no variable, there's no negative. 3 and 8, well, wouldn't be 3, so I guess it would just be 1, because any integer's in the 1 row. Now 3 times negative 220 is negative 660. I'm not real excited about taking a number higher than 100 and having to go through all the factors to see if they add to negative 8. So I'm going to go to the quadratic formula, and this time it's W equals opposite of B plus or minus the square root B squared minus 4AC, B squared minus 4AC over 2A over 2A. So the opposite of negative 8 is positive 8. And then B, negative 8, 4AC. So A is 3, C is negative 220, then A on the bottom is 3. Okay, so you have 8, 2 times 3 is 6, then you have to find the inside of the square root. So you have negative 8 to the second minus 4, 3, and negative 220. So that gives me 2,704. So I find the square root of 2,704, and I got 52. So it wasn't irrational. That means I could have found it on the T-chart. It just would have taken forever. So 8 plus 52 equals, divide by 6 is 10. That's probably going to be the answer I put. 8 minus 52. Divided by 6, there's that. I don't like that. Hit second PRB equals. So negative 7 1/3. It doesn't really matter anyway because that's a junk answer. So the width is 10. Now to find the length, you jump back up here. And now that I know W is 10, the length is equal to 3 times 10 minus 8. So 3 times 10 is 30 minus 8 is 22. And 22 times 10 is 220. So if you multiply those together,